the values of x and y are they're the legs of the triangle there.
Oh,
So,
wait, this part is just like the quick review. It's the exercises.
okay, yeah. All right, let me go grab those and restart here. Okay, so here is question 2.
Yes.
And it says, show that RS and PQ are equivalent. RS and PQ. Okay, so to find RS, you're going to take the X value from S and subtract the X value from R. So it's 4 minus 7, comma. And you do the same thing with the Y, minus 5 minus 3. And then there's this vector notation. So you get minus 3, comma, -2. They're using ordered pairs for the points, but vectors are generally like this. And then you similarly, from P to Q, you take the X value of Q and you subtract the X value of 0 of P, and then the Y value of Q and subtract the Y value of P. So you end up getting minus 3, minus 2, like that. And they're equivalent there. 4 is exactly the same. So let me get a snip of it. So if you take physics at a university level or a level where there's calculus, you do see stuff like this in there. That's just kind of a starting point. So again, you're going to take that X value from the S, subtract the X value from the R, comma, Y value of the S, subtract the Y value of the R, put little brackets around it. Okay, and you end up getting, what we get here, 4, comma, 3. And then similarly, you take this 1 here from the Q and you subtract the -3, bracket, 4 value, 4 from there, minus a -1. Oh, I got the wrong number. This is 5 on the left here. 2 negatives make a positive. And so you get the same thing. You get the 4, comma 5, like that. The other way you could show that they're equivalent is with magnitude. That's probably coming. We'll see what the next question is. So question 9 here. They give you a lot of starter stuff here. Okay, so they give you P, Q, R, and S, and I guess you again have to find the actual vector and then do something with it. So in this case, they want you to find 2QS. So QS you find the same way that you did in the previous problem. You take this X value 2 and you subtract the X value of Q. And then for the Y value, -8 minus 4. And it's always the second one minus the first one. That's just the convention that's given. I mean, that's just the way it's going to be. So,
Yeah.
and then 2QS means to double. It's multiplication, so it becomes -2 minus 24 when you do it that way. Just checking here that the numbers are right. I 2 minus 3 minus 1, a -8 minus 4. Okay. And then the magnitude. So let's say you have a vector. Let me start out. Your vector has components X, comma, Y, like this. They're numbers. So the magnitude of the vector, and usually most books use this double lines for magnitude. It's X squared plus Y squared square root. It's like Pythagorean theorem. So in your problem, it's -2 squared plus -24 squared square rooted. So that's 4 plus, what is that? 24 squared, maybe 576. Yeah, 576 square rooted. And that's the square root of 580, which I guess we should reduce to 290 to 145. 3, does 3 work? No, 3 does not work. 5 and 29. So it looks like it's 2 root 145.
Okay,
They do expect you to reduce that there.
got it.
12. Let's see, 12. 12 is the same. I'm going to go recopy this. We need this given information again. So 12, they want you to find PS minus 3 PQ. So unfortunately, we can't reuse anything, but we'll find PS. So that's 2 minus a minus 2, comma, so that's in there. And then the Y value, minus 8, minus 2, 4 comma minus 10. And then PQ, same deal here. It's 3 minus a minus 2. So I'm using the X values there, comma 4 minus 2. And so that gives you 5 comma 2. And then you need to multiply it by 3. So 3 PQ is 15 comma 6. So when you do this operation over here on the left, where you're subtracting them, you subtract the X's and you subtract the Y's. So
Okay.
we're taking 4 comma minus 10, and we're subtracting 15 comma 6 because I've already accounted for the 3 in front. So it's 4 minus 15 comma minus 10 minus 6. Something like that. And then the magnitude of that you get again from doing the square of -11 plus the square of 16, square rooting that. So big numbers here. This is 121 plus 256. I don't know if that reduces. I'm going to check here. It's not even. So if it's not even, it's generally doesn't reduce well.
Okay.
I don't think it's pretty. Yeah, so this is just the square root of 377.
Got it.
It's kind of like other parts of other classes where like they're not emphasizing this, so you don't feel like that's an important step. It's this vector stuff that they're really trying to make sure you're comfortable with. All right. Oh, and I guess another thing here, they're talking about component form, and I probably should be more careful here. So there's a couple of different forms that you could be asked to write in, and component form is what we've been doing here with the angle brackets.
Yeah.
You can also use you can also say minus 11 I hat minus 16 j hat. There's other ways to represent vectors, and just you should be aware that, I mean, we're on the right track here, but they may, if you went to a physics classroom, they might use different terminology for the same thing.
Yeah.
Okay, so 13 through 20 here, they give you a new set of vectors, but this time they've already given them to you with the angle brackets. And I'm using more of the fish mouth thing. They're more of the, and I still kind of did it. They're more, I don't know, vertical. Let's see, you have 17 and 19. So 17 says 2u plus 3w. So what I would do is like multiply u by 2. And so that gives me minus 2 comma 6 plus 3w, 6 comma minus 15. You can perform the operations as you go, and then you can just write the final answer. I mean, you can add 2 numbers here, 4 comma -9. And that's component form here. So you've got it. You don't want to try and do it all in one step. You can. It's just if you miss even one thing, there's very little partial credit on this.
Yeah.
If it's not right. Okay, 19 is very similar, minus 2u minus 3v. So another way to look at this, and this, I'll just show you this, is you can actually extract that negative and do 2u plus 3v. Generally adding is easier, and then you can just negate the results, but you can also just negate it negate it or multiply and subtract. But I'm going to show you this way just because it generally, we like adding. So negative, and then 2u is minus 2, 6 plus 3v, 6 comma 12. And so you add these and you get 4 comma 18. And then you still have this negative. So you just apply it just like you do with parentheses and other stuff that you know about from math.
Mhm. Okay, got it.
21. Okay, 21. So 21 says to find what is called a unit vector, which is really important in higher levels of math, where there's multiple dimensions and spaces that are considered. But for you, like, this isn't all that important, but a graph, I'll try to show you graphically what it is to give you some reasonable meaning here. So if we were to graph this thing, it means go left 2 and up 4. So the arrow is literally like this. And if we were to find the length of this arrow, we would know to do minus 2 squared plus 4 squared square rooted, and that's the square root of 20, which becomes 2 root 5. And that's the length of this vector here. So like the
Okay.
length is 2 square root of 5. So a unit vectors have a length of 1. And they go in the same direction. So not to skip, like not, oops, let me grab a different color here. Wow. Okay. So the unit vector has length 1. So like this red is your unit vector, and it's going in the same direction.
Mhm.
Okay. Now that's that's what it is. And then how to actually calculate it. You do need this. So the unit vector is your vector over the magnitude of your vector. So in your case, it's minus 2 comma 4 divided by 2 square root 5. And this would be correct, except they don't want you to write it this way. They want you to rationalize and stuff. So you actually, divide each of these by that. So it's minus 2 over 2 root 5 comma 4 over 2 root 5. Because they both cancel with the 2's, I would probably do that first. And then you need to rationalize the top and bottom by multiplying by the square root of 5 here. So your final answer is minus square root 5 over 5 comma 2 root 5 over 5. And the thing that's really interesting about this unit vector is that it has a length of 1, which, if you were really curious, you could figure that out. You could take the square of each of them, add them up, take the square root, and you get that value.
Okay.
23 is similar. So 23 will just do it the way that, we'll just find it. There's no visual needed. You don't have to graph these, but sometimes it's helpful.
Yeah.
You're a good math student though. A lot of math students really need like the visual to like get it. And it's just one of those things. So the magnitude of W is minus 1 squared. So just to be clear, this is minus 1 comma minus 2 in component form. But when you use these bold I's, that's another way they can present it. You have to say, oh yeah, that's minus 1 there in front. But the magnitude is the numbers in front squared square rooted. So this is the square root of 5. So you take your unit vectors W over the magnitude of W, which is minus 1 minus 2, over the square root of 5, which is minus 1 over the square root of 5, comma minus 2 over the square root of 5. And again, you need to rationalize by multiplying the top and bottom by the square root of 5. So it's really similar to the last. And there you go. You have your unit vector. Sometimes you get a question on an exam that says something like the following. It's like, find the unit vector that's not in the same direction as W. And we just looked at a picture of it, like the unit vector is going that way. So the one that's not in the same direction goes in the opposite direction.
Mhm.
and you get that by just negating what you find.
Yeah,
So it's very much the same thing here.
makes sense.
Okay, so 25. Wow, same thing here. All right. Okay, so the magnitude of u is the same thing we've been doing, 2 squared plus 1 squared square rooted, square root of 5. So part A just wants it in component form, just like we've been doing. So it's 2 over square root of 5, comma 1 over the square root of 5. But then you have to rationalize it. So you get 2 root 5 over 5, comma root 5 over 5. And that's component form. B is in the combination of I and J. So all that means is you write I, and then you write the other one with J. And so your textbook uses bold. And I mean, I've seen students try to like make it bold in their notes. The hat is kind of the compromise because it differentiates it from other things that you might see.
Mhm.
But you know, if you can make it really bold, I don't know, then you're doing what they want in the book. All right, 28, same thing. Wow. I mean, this is really good. Like this would have been good for you to do I mean, I remember some sections where you only have one problem to do in each kind of group, and
Yeah,
here
this
they're
was
given
very repetitive.
very repetitive. So this is the first one where the magnitude is a Pythagorean triple. And that's what I would expect you to see on a test, especially if you get a lot of problems. This ends up being the square root of 25, which is 5, which means your unit vector is really nice. It's 3 over 5, comma minus 4 over 5. And so, just a reminder, there's 3, 4, 5, 5, 12, I'm sorry, 5, 8, wait, I'm sorry, 5, 12, 13, 8, 15, 17. There's a whole mess of these Pythagorean triples that could come up, and they tend to be worked in here. So part B is just writing the components, but with the I hat or the I and the J like that.
Okay.
So calculator is now okay in starting with 30, whatever that means. 30, let's see here. Oh, okay, we're getting into maybe some story problems. First one's just a graph. It's the next page. Okay, so what they're trying to get you to see here is that there's really a triangle here, and
Yeah.
they want the X and the Y. So X is, and this is all, it switches to V for the hypotenuse, which I mean, you've seen it as C, maybe you've seen it as R. It's V cosine theta, and Y is V sine theta when theta is down here. So the short of it is that it's 14 cosine 55, and Y is 14 sine 55. So make sure your mode is in degrees when you're doing this. Always check mode, especially if you're taking more than one class with numbers in it. You might do that. Solve, estimating, yeah. So that's it. I mean, that's all they're asking for in 20 and 30. You don't have to make any other adjustments.
Okay.
Just get those numbers. Okay, so now we're up to, sorry, what's the next one here? 33.
Um,
And the magnitude and direction angle. Yeah. So we've already done this, but now the instructor or the textbook here is like, none of these are nice. So if you want decimal approximations, you're going to have to use your calculator. So for here, they first want the magnitude of this vector. The magnitude is, let me just make sure. Yeah, magnitude. So magnitude is 3 squared plus 4 squared square rooted, which is 5 again. And the next thing they want is the direction. So I gave you that formula. I said, okay, it's x comma y is your vector, and the magnitude of your vector is x squared plus y squared square rooted. Well, the direction is tangent of theta equals y over x. Some books just solve this for theta, so it's the arctangent of y over x. So for you, you've just got to do the arctangent of 4 over 3.
Okay. And is that in radian or degrees?
It should be in degrees.
Got it. Okay. All right. 35 is next.
Okay, so similarly, this one has a little wrinkle to it. Is it really 3 and 4? Okay, so the magnitude of this vector is again 3 squared plus minus 4 squared square rooted, which is 5. Okay. The direction though, and this is you really are supposed to graph them. So it's 3 minus 4, it's down here. So when you do the theta, which is the arctangent of minus 4 over 3, you're going to get, I'm not sure what you're going to actually get. Do you have your calculator handy?
Yeah. I'll do
Okay.
that. Okay. It's negative 0.927.
You got to be in degrees. That's in radians.
Yeah. Oh, you're right. Okay. Negative 53.1.
So that's your answer right there, negative 53.1 degrees. It's going this way. You may want to just sort of ask or look at your notes, and because there's certain physical problems where you would never give a negative angle, but that is the correct answer here.
Mm-hmm. Got it.
Okay, so next question is 37, which is just another kind of a thing here. Actually, I'll just write this one. 37. So it's 7 cosine 135i plus 7 sine 135j. So if 135 degrees, if you is over here, and over here, sine is positive and cosine is negative. So this ends up being 7 square root 2 over 2 j, and this is 7 negative 7 square root 2 over 2 I. And so the magnitude of the vector you can actually do by hand here. It's a good calculation. Okay, so when you square this, you get 49 for that. This square root becomes 2. That becomes 4 on the bottom. Plus, similarly, 49 2 over 4. So what happens here is that this 2 and this 2 cancel to make 2 on the bottom. Same thing here. and you get 49 over 2, 49 over 2. So that's being the square root of 49, which is 7. And the way the problem is written from the beginning, I know the 7 was on the outside. That is the that is the magnitude when it's in this form where the angles are the same.
Okay.
So and then the theta is given. The theta is 135. So you actually didn't need to actually do any of this, but it kind of justifies it for you.
Got it.
All right, so 37 we just did, 30, 44, navigation. Okay, so this is a problem where they're giving you the angle, and we assume it's in this direction, which is 335 is over here. Okay, and they're saying I'm flying this fast. So they're giving you the hypotenuse. They're saying the hypotenuse is 530. This angle though is this one right here, which is 5 degrees. No, I'm sorry, 25 degrees, because it's got to make 360.
Mhm.
So to find the component form, okay, so it's the we said x, this is x, and this is y. X is 530 cosine 25, and y is 530 sine 25. However, there's a negative with the y because it's going down, but x is going to the
Mhm.
so you get those numbers, but this one you're gonna negative whatever the number is.
Got it.
So I've alluded to this a few times. There's a physics problem, or this is really all physics here. This is a force problem that you might see in a physics class. They want to know. So there's a physical component to this, but if you look at just this part, this upper triangle, upper force here, it's a triangle, and you want to find the x component and the y component. But I'm gonna go ahead and draw it over here because there's a lot of stuff going on there. It's x, y, 18, 23. So x is equal to 23 cosine 18. Y is equal to 23 sine 18. Okay. And notice like it's going up and then they're pulling to the right. Now, similarly on the bottom one, okay, you have the same thing, you have but a different angle. So your x there is 27 cosine 15 and your y is 27 sine 15. The difference though in the y is that there's a pulling down, so you have to negate this value.
Oh, okay. The word problems are what's hard for me.
Yeah.
Like everything else is kind of easy, but yeah, drawing it out helps.
So then the last step here is you add these together.
Okay.
And so like these are going to combine positively, these are going to combine negatively, or well, it still is probably going to be positive, but okay, so I think that takes us to the end of that part. We can go on to the, I think you sent a law of sines and cosines word problem.
Yeah, we'll probably get through a few of those.
Yeah, there are a lot of calculators available if you're ever struggling with like confirming your answers. One of the things that if after you set it up, that it's just numerical. You're not really doing anything new. So we'll just maybe work on setting these up to start here. So it says during a figure skating routine, Jackie and Peter skate apart with an angle of 15 degrees between them. Jackie skates. Okay, so this is always the hard part, is like, well, what's the picture? So the angle between them is 15. Okay, 5 and 7, and then they want this distance here. Okay.
Oh, okay.
So whenever you're given a side angle side, okay,
Oh, this is a like
this is a law of cosines.
roll back.
Okay,
Okay.
and the like the reference here, I'll give you the reference here, triangular for it. It's A, B, angle C and C. So C squared equals A squared plus B squared minus 2AB sine big C. And so you have all these quantities on the right, and you can just substitute them in and solve for it. So that's a nice starter question. Whenever you're given side angle side, it's law of cosines.
Okay.
And we'll look at the number 2 here.
Yeah, this would be great. Like just draw a picture, show me how to do it, and then I'll just plug
Yes.
in the numbers later.
Yes. Okay, bridge is supported by triangular braces if the sides of each brace have lengths 63, 46, and 40. So this one, we don't really know what it is. There's a lot of different bridge designs, but they're telling you the lengths. They're saying one's 63, one's 46, and one's 40. And when they want the measure of the angle opposite to the 46. So we'll call that, I'll call it big C. So whenever you're given side, 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 all 3 sides, that is also a law of cosines.
Mhm.
Okay. And little c, you can really draw the triangles any way you want, but little c is always, I'm sorry, big C is always across from little c. Then it doesn't actually matter where you go with A and B. But since you're trying to find C, big C, you use the C squared equals A squared plus B squared minus 2AB cosine C. And then this time you're solving for this. Take a look at another one.
Okay.
Number 3 here. This will be a law of sines. Two observers are standing on a shore a half mile apart. So like there's A, there's B, and there's a sailboat out there. They say angle A is 63, angle B is 56. And this is a half mile apart. So notice you can find this missing angle. Whenever you're given 2 of 3 angles, you find the third because it's 180 minus 63 minus 56. You always find that third part here. So I think that's 61. I think that's 61 degrees. Okay. And so whenever you're given, and this is my wording, you won't get this, but I call it an angle side pair. Angle side pair. That means you're going to use law of sines.
Mm-hmm.
And the setup is there's a couple of different ways it's usually organized, but in your problem, well, actually, what are we trying to find? Find the distance from each observer. Okay, so they actually want little b and little a. So to do this, you just pick one of them. We'll pick little a, for example, over the sine of big A, which you know, equals, and then that's where you have to use this angle side pair that you know, 1/2 over sine big B. So for you, this is A over sine 63 equals 1/2 over sine 61.
Got it.
And then you do the same thing for the other one. So probably enough there to get started on that.
Yeah.
There's kind of an assumption I made to make the drawing, but I know you can, if this is the style your instructor is going to use, then then we're okay. Vertical flagpole is attached to the top edge of a building. So it's like, here's your building. Here's the vertical flagpole. A man stands 400 feet from the base of the building. And we assume that like we want the distance. Well, here they want the height of the flagpole. But we assume it's from the ground, even though a person doesn't, they're not quite there. So there's actually 2 triangles here. There's this one to the bottom of the flagpole, 60. And then there's kind of a separate drawing over here. I know in class, they probably will draw these the same, but you really need to separate them for understanding. It's 62.5 degrees.
Yeah.
So this one is not a law of sines or cosines. It's just a right angle trigonometry. Like you want this y value. So the y value is 400 cosine 60 there. This whole y value on the right here, like going all the way up, it is 400 cosine 62.5. And so the height of the flagpole is the difference in the two y's. So we'll call this maybe y1 and y2. The height is y2 minus y1.
Okay. Yeah, that's pretty simple.
But not law of sines, not a law of cosines,
Yeah.
interestingly. All right. So try and set up a few more of these. some classrooms, they have to use this notation with north, a certain angle, west, or you know, they have it's north 42 east. It's very confusing. Your instructor is choosing not to do that. So here's Niagara Falls, and then they're saying Orlando is due south. Okay, Denver is 270 millimeters from Orlando and from Niagara Falls. So actually, I mean, just geography wise, we know that Denver's maybe more over here. So they're saying this is 235 and this is 273. So again, this is a side, which means that you're going to use law of cosines for whatever it wants. It wants the angle at Niagara Falls, so it wants that angle there.
Okay.
All right. Okay, Nicole shines a light from the window of a lighthouse on a cliff 250 feet above the water. Nick is 10 feet above the water line, finds that the angle to the light is 3 degrees. So this is 10. So this is really 240. And they want the length right there. So this one's not a lot of cosines or sines. It's a tangent problem. Tangent of 3 degrees equals opposite 240 over D, and then you solve for D.
Okay.
And this is a little rushed. I will send you the notes here shortly. Let me just draw the last one here. Just get you the pictures here. So fire towers are 10 miles apart. And they have another thing that they spot that's 42 degrees and that's 64 degrees. This one's almost exactly like one of the earlier ones that we did. It's a law of sines where you find the third angle. It's like this problem up here, the ones where they're standing a certain amount apart, like number 3. All right, well, that does take us to the end of our lesson for today. Ella, thanks for scheduling, and I'll send you the notes here shortly.
All right.
Have a great day.
Thank you. You too.
Bye now.